Welcome back, Caymans. Mr. Eicher here. This is the last part of a lesson on slope and rate of change. This is the third page. If you don't have this page, I encourage you to take some notes or print out the page if you'd like. In word problems, we'll do a couple word problems here. In word problems, the average rate of change is the same as slope. The reason why we use average rate of change is because in some functions, the points line up perfectly on a line. But in others, it's not so pretty. You can kind of tell they're still going uphill, but they don't fall all on one single line. So average rate of change, we'll have to pick certain points, like maybe we'd pick this one, and then find the rate of change through those two circled points. Something helpful when you're doing word problems is to know that time is the x-coordinate, and the other variable is the y-coordinate. So if you're ever confused which should go on top or bottom, time is often in the denominator, and the other variables in the numerator. So, number 9, in the Mojave Desert in California, welcome to California, temperatures can drop quickly from day to night. Suppose the temperature drops 100 degrees Fahrenheit at 2 p.m. to 68 degrees Fahrenheit at 11 p.m. Find the average rate of change. So again, the average rate of change is the same as finding the slope. In this context, the change in y over the change in x, or the slope, is going to be the change in temperature. That's the variable that's changing. And then, like we said earlier, time is often the x-coordinate, so this is the change in time. So to calculate that, the temperature started at 100 degrees and it went down to 68 degrees. That was at 2 o'clock and it ended at 11 o'clock at night. So this would be 32 degree change as 9 hours passed. The negative is important there because we were told the temperature drops, so it's going to be a negative. So this is negative 3.5 repeating, and the units there would be degrees Fahrenheit per 1 hour. So the temperature is dropping 3.5 repeating degrees per 1 hour. And just as a quick review, a repeating decimal like this we would say is a rational number, and it's a real number. It's not a natural or a whole or an integer, and it's not irrational. It would be Q for rational number and R for real number. And then the last one, we'll do part A and B, and part C and D is for you as a try this. As part of your Schoology try this. According to Statista.com, the following table shows the number of passengers on cruises in millions from 2009 to 2019. So in the top we have the year, and in the bottom we have the number of passengers in millions. So this number, for instance, would be 17.8 million passengers. It's a lot of passengers. That's the same as 17,800,000 passengers. And I'm sure that's rounded. There's no way you'd get exactly 800,000 on the dot. Like, well, I guess there is. It's possible. But these are just rounded numbers. So find the average rate of change. Find the average rate of change from 2009 to 2019. So to find the average rate of change from 2009 to 2019, 2009 information's right here. 2019 information's right here. Everything else you can ignore for this first part at least. So you want the change in y over the change in x. The change in y is the change in the passenger number, change in passengers. X would be the change in the year. So the passenger change, it started at 17.8, it had ended at 30. Let's subtract those. That was starting in 2009 and ending in 2019. So this would be 12.2, that's negative. And that's from 2009 to 2019, that would be negative 10. So our answer would be a positive 1.22. The units here would be millions of passengers per 1 year. So we're estimating that as each year passes, the number of passengers increases by 1.22 million. So that would be an important number for individuals in the cruise industry. they'd want to know an estimate in 2020, how many passengers might we expect, barring any pandemic canceling quite a few of our cruises. So B says interpret the average rate of change that we had in A. If you include the units, that's going to make it much easier than if you didn't include units. We would say for each additional year, or as each year passes, for each additional year, we estimate there will be an increase of 1.22 million passengers on cruises. This estimate language is pretty important because if you look at the individual change, it's not always a 1.2. It's kind of an average, right? Average rate of change. So it's an estimate or it's a prediction. You could also say we predict. We predict there will be an increase of 1.22 million passengers on cruises for each one additional year. The next two questions are for you. One is calculating the average rate of change from 2017 to 2019. And then it's practice interpreting, and on Schoology you'll kind of do a fill-in-the-blank interpretation. Thanks for watching this video. Give me a thumbs up if you like this video and any other video. See you next time.